Good morning, everybody. Welcome to this PACTRANS Region 10 Transportation Leadership Seminar and Webinar. And this is concurrent with CEE 327. I normally teach this class, but this year I'm on sabbatical. So Yifan is teaching this particular course. We want to invite somebody who is really with a lot of experience in transportation engineering to share their experience with you. You probably joined enough, academic talks, but you don't see a lot of people from the practical world come to share their experience. So today we're really lucky to have Scott Murrell. And from the flyer, you already know somewhat about his past experience. He has over 40 years of experience in transportation engineering and civil engineering in general. He was the chief engineer for Port Authority of New York and New Jersey for many years, and he was also an employee with Federal Aviation Administration, and now he is the director of Applied Research Associates, Aviation Service section. So Scott has a lot of practical experience, also directing research. So you can hear about his thoughts on both the practical side and the research side. And more importantly, we're in a changing world. When there's a change, there's always some challenges. And associated with the challenge are the opportunities, right? So depending on what you want to focus on, you don't want to miss the opportunities, even though there may be challenges. Now let's welcome Scott to see what he says. Thank you, Scott.
Thank you, Yinhai. I appreciate being here today. I understand you're completing your semester, so we'll try to keep this on time. You can get back to your studies. So I don't know if any of you saw the Complete Unknown movie, but this is a Bob Dylan quote, and even I'm too young to really remember Bob Dylan when he got started out, so may not be the greatest reference, but one of the advantages of having a lot of experience is that you learn to you see a lot of changes that happen over the years. When I was in your place, there was a downturn in civil engineering. This would be in the mid to late 1970s, and then as I was coming out of college, the nuclear industry was shutting down in the U.S. So there was some changes going on from there, and over 40 years later, I'm still working as a civil engineer, and I truly enjoy my profession. So here I have a little outline of the presentation. So we're going to go over some of yesterday's case studies, what's happening today a little bit, what we can do today, and looking at tomorrow a little bit. So as Yinhai alluded to, I have experience mainly in the practitioner space. Although I was with the Port Authority of New York and New Jersey, my title was Chief Civil Engineer, and with that I was in charge of design, the design group of civil engineers. So, and at that time, the designs were done in-house. So if you land at JFK on one of the runways today, it's a concrete runway, that was probably one of my designs, that I was the engineer who signed off on those drawings. So, and then when I had an opportunity when I reached retirement age to go and work for Applied Research Associates. And that was a transition from when I had worked with the Port Authority. The FAA was looking for airport experience to come and be an advisory panel for the FAA Technical Center, which is in Atlantic City, so it's not too far from where the Port Authority is located. So I'd go down for those meetings. And I found it very interesting because this was pavement research, which was part of civil engineering. And it was a chance to really influence national standards. So as I was leaving the Port Authority, I had an opportunity. I could have went and done some more designs for, say, airports around the country, worked for a consulting firm. Or I had this opportunity with Applied Research Associates, where I'm at now, which was to support that research as more directly as a contractor instead of an advisor. So that's what I've done the last 9 years. So I have a little bit of both that practical experience of, and it's probably not fair to call it practical. There's a lot of practical research going on. But that practice, maybe go to the word practice in practical, but practicing civil engineering, and then going from there into doing some research projects. So I've I've cobbled together some slides from both the some of our projects that we're involved with at ARA, and then some American Society of Civil Engineers information. So right now, I am the president of the Transportation and Development Institute of the American Society of Civil Engineers. And if nothing else you take away from this, you could see that, yeah, that guy's not really that much that special. But he ended up the president of the Transportation and Development Institute somehow. So I think any of you could do that. So I congratulate you all. I believe most of you in the room are civil engineers or studying to be civil engineers. And we are in demand, so it's a good profession to be in. So let's take it away here, if I can. Oh, maybe that's not gonna. I seem to be locked up.
I think you make this the press.
Down? No.
Just click on the screen.
Try again. Try again.
There we go. There we go. Sorry about that. Okay, a little lag. All right, so I love this example. This was from Amir, Mohammed Amir. He's the director of the Transportation Development Institute. So he's the ASCE staffer that works with the volunteers. And he talks about this in terms of standards development. So as you can see, where'd we go?
I think you hit the flag.
Okay. Okay, so as you can see here, so there's a picture back in 1900 of Fifth Avenue in New York City on Easter, and then you can see 13 years later, with all the horses, and then you don't see them anymore. 13 years. So quite a disruption in what was going on, at least in New York City. Maybe not the entire country at that point, but in New York City. So related to that, so you had all these vehicles, right? And there was really no rules of the road. So there, and if you've had in your transportation courses, maybe you've seen this reference, but there's a standard, national standard, manual and uniform traffic control devices. One of the committees in TDI is a reviewer and provides input for this. And So it was first released in 1935. So it was over 22 years beyond when the cars really had market penetration, at least in major cities. So I don't think that's me. It's back. Okay, so I don't know. Oh, go back. Well, okay. So yeah. So you could see, you know, I just want to keep this in mind for later because we're going through some significant changes now, and can we really wait 22 years for the standards to do that, to address the changes? So I'm going to stop using this thing. Go much quicker if I. Okay. So another big change. So the jet age. So, right, used to be all intercity travel. This picture here, the train of tomorrow, was from the late 1940s, right? I mean, by 1960s, all the passenger railroads were going bankrupt. So the jet really, you know, transatlantic shipping, not shipping, but passengers to go back and forth, especially in my area, for Europe, over here, maybe to Asia, right? Gone, right? You only cruise. So big change. We used to have these palaces in the center of the city for those who are interested in development. You know, we used to have these train palaces. So that's a picture of Penn Station in New York City, right? That is the classic example of why we need historic preservation, because they threw that down and they put up Madison Square Garden. And I've been to Madison Square Garden, and it's not that pretty. And sometimes it's not that pretty what goes on inside with the Knicks. So now the palaces are really airports now for a lot of countries. Right, have replaced the train palaces for, you know, and the public gems, you know, architectural gems making a statement. But a lot of times they're not located, you know, they're not downtown anymore. So then there's interconnectivity with them. So a lot of disruption happened with this. My third example is the microprocessor revolution. Now you're all in an area, right, that is all in on the microprocessor revolution. They've taken, you know, and it's changed. You know, you guys know this better than I do. Okay, what you can do now, right? All I can do is I can give you that view of what was going on when in 1982 I started in, and so my first thing in this, I love the Frieden computing machine because my father had one. My father was a civil engineer. He used to bring that home instead of a calculator. So, you know, civil engineers were pretty strong guys back then. You know, but also, and then you have. It's kind of funny, the open floor plan for offices, well, it's not really that new because that's like a design office, right? Everything old is new again, but it's really, you know, everybody knows, right, the phone, right, you know, yes, you know, there's more computer power in this than in the Apollo 11 and all that, but it's really changed. Like when I started in a design office, it was, we would have drafters. First they were draftsmen, then they became drafters, right, in recognition of the sexist term. And then they would do a pen on ink. It was Mylar. And it would be punched Mylar that and there was a bar that you would stack the sheets on. So you'd have the border on one sheet, and then you would like border for the project, and then you would do the details for the one drawing on that, so there'd be layers. So it was almost like with the CAD layers and the BIM layers, it was physically with plastic sheets at that time. So, and in the office, you know, you had the engineers, you had the drafters doing the drawings for the engineers check them. And now that's, you know, you all, you know, if you go into design office, you're going to be working on the computer, your design, and producing the drawings. So big changes. And now with the BIM models, BIM, you know, being involved and taking everything you've done and continuing to be able to use it during the use phase of projects, it's just, you know, it's incredible advancements. The speed and delivery, and there is a common theme on some of these things, like with the jet age, speed. The Microsoft processor, speed. So it's always been that. You go to like Disney World and you go on the Carousel of Progress, if you've ever been on that, and they talk about, you know, each section. Well, I could go across the country in 3 days, and then it became, you know, how long it took to cross the country. And that continues that. That's nothing new about this everything faster. So let's talk about today. So is AI, you hear about, is AI hype? All right. So around 2000, there was an occurrence, the tech bubble. It's very famous in the financial world. In fact, when I worked for the Port Authority, my office was in the Trade Center. That came down in 2001. And some of the space that the main office moved into was freed up because of the tech bubble, with companies going out of business. So, but was it really a tech bubble when you look now back on it? Like, maybe the stocks were undervalued at that time and not overvalued for what's happened since then. Now some players dropped out and there's consolidation, but so I would say, you know, there's some talk about maybe AI is overvalued in the stock market, or maybe it was last week. Stock market's been down a bit the last few days, but I'm not a believer that it's a bunch of hype, and even a simple old guy like me can realize its value. So bear with me a couple minutes here, because this is my my home turf, pavement engineering. So the FAA design program, national standard, actually pretty much a worldwide standard, except maybe some of the French-speaking countries, but national standard on how to design pavement. So the structural design of the pavement is based on a finite element model. It assumes that the pavement is lying flat on its support, right? And it only looks at top-down, bottom-up cracking. So it calculates the stress at the bottom of the slab, and then we see if the stress is too high, that, you know, or how many repetitions to failure, right? Doesn't look at where the top, when cracks go top down. So, and what happened was when they opened the FAA Tech Center and they did the first set of slab testing, they're getting all these cracks that were top down. And they had designed everything for bottom up, but it's an enclosed facility, right? So the slabs were not being moistened throughout their life or anything. They were just dry sitting in there, and they ended up cracking them. So when around this time, the FAA said, you know what? Right, the maximum slab side allowed was 25 foot by 25 foot for unreinforced concrete pavement. They said, you know what, we're going to make that smaller, because we don't really have a great way of calculating this. So, but practice has shown, there was a study done that looked at a lot of pavements, and they said, you know, it looks like the smaller slabs work better. Didn't consider the support underneath the slab. It's just, so the FAA recognized this in the last few years, maybe about 4 years ago, and said, we want to do a little research and look at this top-down cracking phenomenon. So the company I worked for competed for that and won the project. So what we did is we applied, finite element analysis, but we considered slab warping and curling as part of this analysis. And you can find some things here like, the goal here was to add a critical top-down stress and do that analysis. And it was recognized that that maximum stress doesn't occur right beneath the gear. It can occur, and it depends where it sits on the slab, where it appears. And and the magnitude goes all over the place. So, our company did a machine learning model, right? So it's a modular deep AN, and don't ask me what that means, okay? Dr. Ashtiani, I have the paper at the end. Okay, so there is a FAA research project you can take a look at, right? But it looked at four-layer and three-layer systems. So we ran finite element. So in the program right now, by the way, I forgot to mention something. So the reason they picked that simplified model was because it takes about a half hour to design one slab, one case, with picking the thickness. You pick the thickness, you pick the strengths of all the materials, the modulus of the base and the subbase and the flexural strength of the concrete, but it takes a half hour to do one. So now, when I first started, we didn't have personal computers on all our desks. So half hour to me, that doesn't seem too long. Half hour to you is like, holy cow, that's a lifetime, right? And that's how the speed has changed. So that's why it had this simple model. So ran 377,000 cases. This project was to look at thick, really for the heavy, like SeaTac type pavements, but it was expanded to cover GA pavements. So general aviation, that is, sorry. So we developed these, machine learning models. Here you can see. So this is the results. So you have the, from the finite element analysis versus using the predictive tool, that was developed with the machine learning, and we have very good, correlation. So great, it works. So we, first one's just, it worked, and we have it set up so it can be added to FAR-Field, which is that national standard for pavement design for airports. And then, but it's down to a fraction of a second, so it's just seconds to do a design, where it was a half hour to run through one case. And it gives us the entire stress distribution, not just the peak. So you can look at it because they're not uniform aircraft, so you can look at different aircraft, how that works up in fatiguing the concrete from different aircraft operating over the surface. And we, so this is like the ARA commercial a little bit. Yeah, we developed a new ML model for this type of research. It's within 5%, which is very good, because even when you get down to it, there's that old saying about, measuring to thousandths of an inch and cutting it with an axe, all right, the precision you need. This is plenty good precision, because if you're within a half inch, it's basically within a half inch of thickness. That's what the contractor has their slip form paver set at this thickness, or if it's side form concrete, the forms are this high, so that's fine. So it all worked out. For those who have that interest here, that's the the paper that was just published. It was finished a little bit, but it got through the publication process with the federal government, so that's available to look at. So all right, so what did we get out of this? Well, this, because of machine learning being developed and now application and research, well, we made a design quicker. Big deal, right? But we couldn't really decide how big the joints need to be on the slab. And joints are kind of problematic on concrete pavements. Tend to get some spalling on the joints. So if you can optimize the joint spacing, that's a big win in performance, right? And the other thing, we're not sure if we're making the pavement too thin because we're only looking at the bottom stresses. So if we're making the pavement too thin, then that's another performance issue. So the real potential here is on the optimization of the design. It's not on the design process. But there's two benefits here. So this is just in airfield pavements, right? Never mind all the other applications within civil engineering and beyond. Oh, I thought you were taking a picture of the slide. So, okay, autonomous and connected vehicles, all right? Yinhai's forgotten more than I ever knew about this, okay? But there's a million applications of this, so I just thought this might be a little different. Maybe something you haven't heard. So there's a initiative looking at autonomous airports. Okay, so there's 3 applications. So one of them is mowing the grass at the airport. All right. The other one is perimeter security, and then the third one, FOD. So FOD is its name has changed over here, but it's foreign object debris. It used to be foreign object digestion when I started out because they were worried about things getting sucked into jet engines and damaging the jet engines. And that tragic case with the Concorde in France was an example of FOD, where a piece of tire got sucked up into the Concorde's engine. I think it was Continental Airlines tire had blown or something, and that caused that crash. So FOD is a very big deal with airports. So, in fact, when we inspect pavements, we calculate a FOD potential number. So these are 3. So there is a project going on in that space. And it's these are a group of the participants in this, including the military a little bit and a bunch of companies. So it's again for safety. So it's to reduce, because when you have humans involved, there can be human error. Right? So, and some of this, so like FOD detection now. FOD detection now is an operations agent at the airport, or if it's a small airport, it might be the airport manager driving around looking at the pavement and see if they spot something. So it's pretty much FOD detection. And we send the sweepers out, regularly, right? So this allows you to maybe go out and, have this robot, looking around to see if there's anything and then picking it up. So it's that type of thing. So there's a command and control test as a part of this research effort, because you want these things talking to each other. And then there's and then they want to make it scalable for national adoption. So and this project is a congressional earmark. So when you hear all earmarks going away, it's stuff like this too. But this project was earlier funding, so this one's going to happen. So they picked a location at Atlantic City International Airport to try it out, which is the FAA Technical Center is located on the grounds of that airport. There's a National Airport Pavement Research Park located on the airport grounds also. It's a different organization. So, and they were one of the organizations involved in this research. And so you can see the white is they're going to go and, have it patrol the perimeter and test getting past the device. And, the blue will be this FOD sweeping and detection test, and then some mowing. So this is another little area, and this does include like the other things on the airport, like maybe automated tugs for the planes. I don't know. I get a little tired of waiting for a ground crew. You come in, long flight, you go, and then you wait because there's nobody at the gate to receive the plane. So I'm not sure what's going on in that space, but there's other potential there. So federal policy, so if you're in the research space, this has been a little scary last few weeks. So I just want to put some trends. I'm not commenting on, I'm not getting political, I'm just listing them, okay? So don't shoot me, but these are the trends, okay? But if you did happen to AI is in with this administration. So you can't deny that. There's a focus on maybe onshoring more, U.S. manufacturing, energy production, and that's not just fossil fuels, but even like, it seems like nuclear might be making a bit of a comeback. So, and then the jury's out on, I'm not sure, I've heard different things about resilience, because resilience is getting lumped in with the climate change a little bit. And I think, even the most fanatical climate denier, I think wouldn't have a problem with resilience. So I think resilience is something that may end up being positive if we can get the word out. And then, whether it's reduction in spending or reduction in spending growth, listen to Washington keeping the books, it'll drive you nuts. So, and then as I mentioned, climate change seems to be being pulled back in that area, and DEI, of course, and then the size of the executive branch, maybe. So that's where we are today. Could change tomorrow. So, and even if it's not tomorrow, it could be a couple of weeks. Things change. So, it's not the first time climate change has kind of been pulled back, and then it comes back. So what do we do? So one of the most important things we can do as engineers is communication. So for you starting out, my advice is there's a lot of engineers who can do the math, do that work. But the communicators are the ones who get further in the company, certainly private sector. You get out there, you do presentations like this. Is this something I'm comfortable doing? No, not particularly. This is stressful, all right? But you do it. So private sector, you have to sell. You have to, and it's not a dirty word. It's really making your case. So right now, there's a big chopping block on, but the case needs to be made for research and how this country and society benefits from it. So communications. So personally, again, don't shy away from getting chances to work on your communication skills. First time you do publicly speak, it's not going to grow great. It's not. You'll get more comfortable with it. All right. So again, marketing and communications plan, and this is a little bit focused on what's happening in the research space now. Don't get discouraged. So we chase a lot of projects. Do we win most of them? No. All right. So I apologize for the baseball analogy, but there are, a relief pitcher goes out, tries their best. Some days, strikes everybody out, they win, right? Just like your proposal, you win. There's other days, you go out there, you get beat up, right? You don't win the project, okay? More days, but a relief pitcher, next day they come out and they're pitching again, right? They don't wait 5 days, they're out, right back at it. And so don't get discouraged with it. So that's a life lesson, okay? So volunteering. Volunteering is a great way to meet people. I never would have met Ian High. I never would have got this sweet gig coming here to talk to you today if I had never met him through volunteering. So, and it's just good. It's good, if you have, you're engineers, you have a thirst for knowledge, you're always trying to fix something, make something a little better. It's great to meet people with different views and approaches. So, and then the other thing is, you should, in the case like now we have to make a case to defend research expenditures, right? And I think there's a teaming that needs to be done with that. It's not going it alone. So here's an example of marketing communications plan. So sorry, back to pavements, right? But it's there is a airport asphalt pavement technology program. Gets some money in the funded by Congress and through the FAA. And so there's an asphalt one and there's a concrete pavement one. So for the asphalt one, they just got proposals on this project. So it's all about marketing their research results. We have to crow about what value comes out of research. Not new. We've done that before. TRB's been all over that, and other research counts and all this, right? But we have to redouble those efforts. And this is this organization, the National Asphalt Pavement Association, is running this research program directly. They're doing this, and it's just ready. It just aims to promote, what the innovative solutions out of their research and get them into practice, so that there's value coming out of it. So okay. As far as not going it alone and teaming, I'm going to break off. I'm wearing my little T&DI pen, so I'm going to talk about the ASCE a little bit. So hopefully many of you are in the student chapter here, if not everybody. All right, but it's a big organization. But there's I guess it's in 2027 it's celebrating its anniversary. I forget what number it works out to. And then but you got this big organization. All right, now my father was a civil engineer. He was in National Society of Professional Engineers. He spent time there. Worked with the American Water Works Association. So my organization, volunteer organization, has been the ASCE for a long time now, and it's been it's a great place if nothing else, for networking. But you can learn a lot from participation. So the ASCE has, among other things, all these publications, but the ASCE is a standards issuing body, or it has a group subsidiary or something. So there are famous, in some other classes you might look at ASCE 7 for building design loads. For the transportation space, there's an automated people movers standard that's published by the Transportation Development Institute. Interlocking concrete pavers, porous concrete pavers standards are all published. So it has that, and it really advocates for our profession. And I forgot to say at the beginning, I work for the Port Authority. I talked about that I'm with Applied Research Associates, but my profession is civil engineering. It's not about who I work for. It's what I'm practicing. So, so with as advocate for the profession, the best thing they did is this report card. There's a new report card coming out on the nation's infrastructure, March 25th. So that's something to watch out for. And that has been a great advocacy tool that the ASE came up with. When it comes out, it usually is on the news across the country. It gets some mention. They go before Congress. They talk about it. The other thing the ASE does is they have a legislative fly-in that they do where they send people in. I don't know if have you ever done one? So, yeah. So I have not. So, but you go in and you meet with your congressional delegation and talk about, things that are important to civil engineers. So there is a way to have your voice heard, beyond your individual voice. You have an organization, and I would suggest as civil engineers, this is the one. So they even have a movie. They actually have 2 movies, okay? But this is the earlier one, Dream Big. So, they feel that over the life of that movie, they'll get 20 million viewers. So 8 years ago now, but it's in the IMAX theaters. So really good advocacy group for civil engineers. So, okay, so earlier I had talked about 22 years, right, for the car, right, penetration of the car into the personal travel market to the adoption of the manual uniform traffic control devices. Well, this is something that's in the ASCE strategic plan. So they're already looking, so this is what they're looking at, what's going on now, and it's this development in adoption of emerging technologies. Part of that is linked to standards. So, and as a result, they have a initiative to look at future-ready codes. And we don't need, this should be a cross-section of the society doing it. It shouldn't, in every way, it shouldn't just be, old guys like me who don't really know, right? I could tell you what happened, right? You're probably better suited to tell me what's going to happen. So I think this is a good effort, again, a part of the, this is kind of my ASCE commercial in the middle here, so I apologize for that. But so let's talk about tomorrow, which I think, so part of tomorrow is, and I'm back to some slides that I got from ASCE. So is anybody played with the Mega City 2070 project at all from ASCE? Okay, or the future. So ASCE has this, so we better do better on market penetration, high. So they have this future world vision, so which has just been in the last couple years, and they were nice enough to put my name on that. So the idea here is to really change the mindset of engineers to start thinking about tomorrow more. So when you look around, you can see a lot of examples of civil engineering products that are 100 years old. So when you go into practice in the coming years, you're going to be designing the future. That's how it is in civil engineering, especially on the bigger projects. They're too expensive. They're going to be in place. So we have to think about the needs of tomorrow in conjunction with today. So that's why some of the client science is important to look at that. So, if you're going to do resilience, you should have some kind of assessment of the risk, right? So you have to look at that. So this is kind of what, some of the questions proposed. And then it's this global initiative that we've done to think about it, as I mentioned. Okay, I kind of said it in my own words there. So and the strategy is to, and I think this to me sounds a little bit like a marketing firm maybe came up with this, but it's definitely true. You know, we need to stimulate the discussion about what the future is going to be. We have to get everybody involved. We have to debate. You know, it's got to be it's got to be safe to exchange ideas. It can't be one way or the other. And then in the end, we really have to imagine what the future is and maybe reimagine how we're doing things today to have things flourish in the future. But it's really, this whole effort is really to inspire the next generation of engineers is the bottom line. You can go through the various steps along the way. So the way they did this is they got a real cross-section of experts to weigh in on this, the development of this vision. And right next to me is one of your local, Roger Millar, right, who just stepped down as Secretary of Transportation for Washington, and one of a past president of TNDI. Before they dropped the standards, and then I could be the president. No. But you could see. So there's and all kinds. If you get a chance to look at this, it's being recorded, and if you have the interest, you could see that it's like structural engineers, it's financing people, it's got an astronaut in there, right? So looking at space. So it's a really wide range of expertise that was involved in it. So, and what they came up with are these 6 as what's going to affect tomorrow. And I don't know, you think they missed anything? We're living this one now, right? The policy and funding. So, and I didn't even mention like nanomaterials or nano. I talked about the microprocessor, not the nano processors, right? Quantum computing, right? There's a million things going on that are going to just change the game. So this is. Alternate energy. Even if we we have to use some fossil fuel to hold us over till we get there, and then of course my favorite, the autonomous vehicles, because I'm getting older now, as you can all obviously see, and I want that car to come pick me up when I can't drive anymore. All right, so very selfish that way, And if you don't like climate change, you could call it extreme weather. All right, I write an article for every month, pretty much, for the TNDI website. I call it my sermon, and 2 of my articles were about either flood or wildfire, right? Disasters, and I've only been in this position 6 months. So let's see if this will work. Oh, I think it's. No, it's. If it's because it's trying to run it off the drive. I have a little video, I think. I think I have it.
Part of the challenges.
It worked when we were practicing. It's okay. I don't want to. We'll skip that. I was ready for that. Okay. So we have a second movie that's been out like the last, I guess, year and a half now. I don't know if you've seen it, but it's about the cities of the future. And we got John Krasinski, not bad, huh? So Jack Ryan, or what is he, Jim in The Office? So, and it's all about this. We have all this tool. If you ever get a chance, take a look at it. It's this Mega City 2070. It sets out a scenario on the introduction. It's like so this was all kind of started in 2020, so it was looking 50 years out, and it was like a $50 million population city, and talking about what's going on with the climate and how the changing and people moving to the city, and which I've seen some in certainly ahead of the pandemic. You would see a bit of that up in the Northeast, that people were moving back to the city, especially your age. They were going in and living in the cities. And it was talking about everything. We didn't talk about drones, right? It's another maybe danger. It doesn't have to be on the ground. The autonomous vehicle can be in the air, right? So yes. So this is the the future. I don't know. You're in some respects you're seeing it now, because, like I had said, we're building things for the next 100 years right now. New bridge goes up, major bridge. It's not going anywhere. What's crossing it may change, but the bridge. So you're starting to see the future, and you'll help with shaping that in your careers. So I am not going to keep you here late, because I understand you're in finals, and I appreciate that you're forced to come here today. But I do appreciate your attention, and I really wish you the best of luck with your finals and with your future careers. So.
Thank you very much, Scott. Now let's open for questions. Any questions? Maybe let me start one so you guys can think about your question. Scott, now you are the president of the ASE Transportation and Development Institute. You were the chief engineer of Port Authority of New York and New Jersey. So you have experience for like the public agencies like FAA, and then the private company, ARA, and like a bigger authority, Port Authority of New York, New Jersey. Now you are also leading this volunteer organization. So what's your top secret to be successful in these leadership roles?
I guess you have to do the work. So with my career in the Port Authority, I started out of college, not a top-tier engineering school by any means, but did the job. So I worked my way up from entry level, and I just worked hard and had an interest in my work. And if you needed to stay late one night to fix something, and I would do that. And then as far as the ASE, it's kind of a little bit the same story. So I was a student member. I get that wrong. I was not a student member, but I joined after I graduated. And then I was in the local chapter for a little bit, and then I started getting invited. I got involved with this FAA work. So then I was asked, and to credit Port Authority at that time, would send me to meetings with the FAA and then say, well, you know, they want us on this airfield pavement committee for the ASCE. Could you go and so I went and volunteered and did that. And then I was on that for a little while, and they asked me, because some of these committees, if they see you're active, they're going to want you to do more. So they wanted me to be one of the consultants that I knew. He asked me, hey, can you be my vice chair of the committee? I said, sure, which puts you on the track to be the chair. And then I was with the chair. Then I was with the council. So there was a transportation council, what was it? I forget which. There was a design council initially, and then they changed it. And then I moved up. And then I got somebody said, hey, can you sit on the board, you know, after being the council chair? So I was like, yeah. So they named me to the board as a volunteer. And then eventually I went off, cycled off the board. And then after a few years, got to a place where I said, okay, let me see if I can serve as the president. And I was elected president. So it was wasn't, you know, helicoptering into an organization or anything. It was just working through this system. So.
Thank you, Scott. So clearly the keywords I learned from what you just told us, one is volunteering yourself. And the second is, you know, demonstrate your capability and communicate well. So any questions from you guys? Use this, because there's an online session. Yeah.
I guess I just wanted to ask about, so you work a lot in aviation.
Yes.
But I know that there's kind of been like talks of like a high-speed rail or something in California. Do you think that's like a feasible solution, or I guess what do you think is the future big long-distance travel option going forward?
I think high-speed rail's value has been demonstrated worldwide. So I count it out. I think there's a mix, so there'll be a range. I mean, and it's not really super high, right? I'm in a region that actually has the Acela, right, which is like, it's not really that fast, right, compared to other countries. But I think there's a mix. It's just, you know, there has to be a willingness to make the investment, because it's quite an investment to get it done. You know.
Thank you.
You're welcome. Great question.
All right, maybe we can allow 2 more questions. I don't want to hold you guys too long because you'll be preparing your finals. Yeah.
Just slightly off topic, but I was wondering with your expertise, you might have some insight on like all the current policy changes regarding the FAA and layoffs and things like that. If you think there's been a reduction in kind of safety standards across the nation. I mean, we've seen some news about crashes and stuff, but I don't know if that's just exacerbated by the media, or if you think there's been a real safety impact or not yet.
You know, I mean, I can only report what I've heard, the same thing you, right, that the administration, you know, is kind of saying, you know, that no, it was not in positions like they got rid of a lot of probationary employees, and it wasn't in the safety area. I don't really know enough of it, but it does seem like when there's an accident, seems like the reporting goes up also on anything that happens in the space. So, but yeah. I don't know. Did you see that Midway? That was scary. What happened in Midway? Yeah. Where that runway incursion. That's the other part. We have a contract also with the FAA doing airport safety, and we look at runway incursion mitigation.
All right. The chance for the last question. Anybody want to take this? All right. For no more question, I think if you have some specific things you want to talk with Scott, he'll be around for a little bit longer in this room. So let's give Scott another round of big applause.
Thank you.
He flew a long distance from the East Coast, the red-eye flight. You can imagine he's pretty tired. But really, I think his talk has been really thoughtful, and that's a very valuable experience that you guys can learn. Thank you again, Scott. Now the seminar is over. Thank you.